Let's look at integration by substitution. What this is the chain rule backwards. So if you are one of those and you did the shortcut, which is what I do on the chain rule, you'll see here that you kind of have to go through and pick apart the pieces of your function instead of doing it shortcut wise. What I mean by that is if you were doing the shortcut, you took the derivative of the outside times the derivative of the inside, and you didn't write all the stuff over to the right, meaning like y equals u squared and then u equals whatever. And so what we're looking at here, since this is the reverse of the chain rule, is we're looking for a composite function. So in other words, what you're given is going to be a product of two factors, and one of them you should be able to recognize is the derivative of the inside of the other one. So when we do substitution, we substitute our function, we call it u, and then as you can see, this dx says that's my variable of interest that I'm integrating. Well, there is no x. So you just have to actually substitute to match. This du has to match my variable of integration. So if y equals f of x defines a differentiable function, then dx is the independent variable and dy is the dependent variable, which ends up being our product of our derivative times dx. So all this is saying down here is when you took the derivative of x squared, you know by now, hopefully, it was 2x. A lot of times you saw this just written as f prime of x, but this dy dx is the same thing, right? Because the derivative is the change in y over the change in x. So all we're doing from this step to this next one is bringing the dx over here to the side, because all of this you're going to see is going to be used to replace when we set up our substitution. Okay, let's see if we can figure out how this is done. So again, what you're looking for is when you look at this, first thing is you see a product, and so we're reversing. In other words, there's not a product rule for integration. We have to use the substitution. And hopefully your eyeball is going, interesting. This piece right here is the derivative of this inside. And that's what you're looking for to be able to do this substitution. So what we do is we say let u equal this piece, and then this would be the derivative of u. So I have u equals the inside, then the derivative of u with respect to x would be this 2x plus 2, and then I simply bring the dx over here. Why do I bring the dx over here? Because now this looks exactly like that, and so I can do my substitution. Where I see this, I plug in a u. Where I see this piece right here, I plug in my du. And now this is very easy to integrate because I can just simply use my power rule. And so the substitution makes this certainly way easier to do anything with it. And so with my power rule, remember that says to add 1, because we're doing the opposite of derivatives. So to add 1, and whatever you get, the denominator, you're doing the same thing, and then plus your constant. Well, you're not finished because you have to go back and plug in what u is. You have to substitute back. And so I substitute what u equals, and so nicely I can see this gives me my final answer, and I could check it by taking the derivative. If I take the derivative of this, I better get that back. So I take the derivative of, I just pulled this 1/6 out front. I take the derivative of the outside, meaning bring the 6 down, leave the inside alone, subtract 1 from the exponent, times the derivative of the inside. As you can see, the 6's cancel, and certainly enough, you get what you started with. So if you take the time on these to go back and check them, after you find the antiderivative, remember this is your original function, take the derivative of it and you should get that back. All right, let's look at some more examples. Now, typically when you use substitution, you're going to substitute u for what's in a parentheses, or what's in a denominator, or what's in an exponent, or what's under a radical. And those are your typical what you're going to substitute for. So in this case, I end up letting u equal my denominator. And so if I take the derivative of this piece right here, you see I get 4 and then dx. But the problem is, I don't see no stinking 4 over here. If there was a 4 up top, this would be perfect. Well, there's no problem with that, because all I care is I want to get this dx. Well, I could divide 4 on both sides, and I just end up substituting 1/4 du instead of just du. It doesn't matter, because this is just a constant, that's going to get pulled out front anyway. And so what I ended up doing is I substituted my 4x plus 7 is my u, and then I substituted my dx as 1/4 du. So now I'm to the point that I can integrate this. I pull the constant out front, the 1/4. The antiderivative of 1 over u is ln of absolute value of u, okay, just because you have to take logs of positive numbers. But remember, if you took the derivative of ln of u, what would you get? 1 over u. So that's why that's the antiderivative. And I get my answer. And so again, what's so nice about this is plugging this back in, I see that by substitution, it made something very complicated pretty easy, or easier, because this just became 1 over u, which was easy to actually find its antiderivative. How do you know if your answer is correct? You're going to take the time to check it, right? You're going to find the derivative here. Uh-oh, looks like I'm missing a d right there. You're going to find the derivative of this, so I pull the 1/4 out front. I take the derivative of ln of anything is 1 over the anything times the derivative of the anything. So 1 over 4x plus 7 times the derivative of 4x, which is 4. And as you see, again, the 4's cancel, and we get our answer. Okay, what are we going to use for our u? If you're paying attention, remember I said typically it's what's in parentheses, it's in a denominator, it's under a radical, or it's an exponent. So let u equal this exponent here. Find the derivative, du, with respect to t. So I bring the 2 down, I get negative 2t, and then I've brought the dt over. And so once again, I look over here and I say, well, I see a t and a dt, so that's mighty fine, right? But I don't see a negative 2. No problemo, we just divide it out. So I take and I divide both sides by negative 2. And now I have my t dt. So what I did this step is all of this is being multiplied. I just rearranged things to show you that this is being substituted negative 1/2 du. And then my e to the negative t squared becomes e to the u. Again, I'm home free because I can bring the constant out front. The antiderivative of e to the u is e to the u. Okay, and so the constant comes with it. Now, a lot of times students will ask, well, what happens to the du part? Probably the best way to say this where it doesn't get really complicated, but this is like with derivatives with respect to, that's just my variable of integration. So you could say after you find the antiderivative, that's this little s thing, my integral sign, is canceling that out. Okay, and so you see that piece goes away. Now don't forget your last piece, plug in what you have for u, and you have your answer. Not sure if that answer is correct, you're going to check it. And so you find this derivative, the derivative of negative 1/2 e to the minus t squared. Well, the negative 1/2 comes out front. The derivative of e to the anything is e to the anything times the derivative of that anything. So I take the derivative of what's up top. I see the negative 1/2 and negative 2 cancel, and I get my answer. Let's do another example. What do you think u is going to equal? You know, right? You got it, you got it, you got it. It's what's under the radical. So I take the derivative. I get 3x squared dx. I look over here and I say, well, but there's a 4, but there's not a 3, so I need to divide it out. So the only thing that's going to get, and this 4, who cares about it? I can move it out front. The only thing that's going to be substituted 1/3 du is the x squared dx. So I do that. I bring the 4 out front. Where I see x squared dx, I plug in my 1/3 du. Where I see the x cubed plus 5, I plug in my u. I just bring the 1/3 out front, so 4 times 1/3 is how I get the 4/3. And now I'm ready to do an antiderivative, which says to add 1 to my power. Do it here on the bottom. I get 3/2 over 3/2. And then I get 8/9. How in the world I get 8/9? Remember, when you're dividing, you flip and multiply. So this is 4/3 times 2/3. Plug back in u, and you get your final answer. Might look like a doozy, but it's good practice of the chain rule. And so if I want to check this, find the derivative. I just brought the 8/9 out front. I take the derivative of the outside, so I brought the 3/2 down. I subtracted 1, left the inside alone, times the derivative of the inside. I can see 8 times this 3 is 24, or I'm sorry, this 3 is 24. 9 times 2 is 18. So that's how I get this piece. And so now I say, well, I could actually take this and do maybe some canceling by moving things around. Okay, so in other words, if you look here, however you want to do this, remember all these 3 pieces are being multiplied. Okay, so all 3 pieces are being multiplied. So that's 24 times 3, which is actually 72. I don't know why the 2's not showing up there. It's actually there, but it's not. It's there, but it's not there. I'll put it there. There it is. You're probably wondering, how in the world should go from there to there? So in other words, 24 times 3 gives me my 72. That's not showing up. Over 18, and 18 will go into 72 4 times. And I look here, and I look up here, and I say, woohoo! That is correct. Caution, a constant factor can be moved across an integral sign, but a variable cannot. This is where you see me, well, we don't have a 4. What do? We divide it out. That's okay, because that's just a constant, but you can't divide variables out and stuff. So in other words, if you have something like this, and I'm trying to use substitution, so I have the inside here, and I take the derivative, I get 4x cubed. Well, that's x squared. You can't say, oh, well, I can just move an x. You cannot move a variable, okay? So if that happens, which it won't in this class, but if you move on to higher level calculus classes, then you just can't use this method. Let's look at an actual application. It says the market research department of a supermarket chain has determined that for one store, the marginal price at X tubes per week for a certain brand of toothpaste is given by this. You can already see you're given the derivative, but it said marginal. So that's how you knew it was the derivative. Find the price demand equation. So in other words, I'm going backwards. I want to find the antiderivative. If the weekly demand is 50 tubes, when the price of a tube is $4.35, and then find the weekly demand when the price of a tube is $3.89. Well, let's do the first part. So I know I want to find the antiderivative of this. Okay, so that's what I'm looking at. This piece right here, I can just pull that out front. So what I'm finding is the antiderivative of e to the something. So that something I make u. I take the derivative of it. All I need is dx, so I end up dividing that out. Remember, there's a 1 there. That's 1 du. So I divide both sides by the negative 0.01. I take this and substitute for my dx. And so that's why you see this piece right here. And then I substitute this as u. If I divide that out, I get 1.5. The antiderivative of e to the u is e to the u. And then I plug back in what I substituted for u. Now, I find it funny that your book has you use substitution for this. And the reason I say that is because this is actually one of those special formulas, but it's a nice little practice of seeing things with exponents. All right, so find the price-demand equation. If the weekly demand is 50 tubes when the price of a tube is $4.35. Well, remember X, so right here is the number of tubes. So I can just simply plug in 50, and when this equals $4.35, so I need to solve and find the constant. So I'll multiply all this stuff out. Then I chunk that to the other side and I get my constant, which gives me my entire price demand equation now. Before, you just had the plus C and you needed to find that. Now that I have this, I can answer my second question that says find the weekly demand when the price of a tube is $3.89. So this, my price demand equals $3.89. I need to solve it. So what do I do first? I chunk the 344 to the other side. I then divide both sides by 1.5. Just that crazy algebra stuff you remember, right? And then, do you remember how to solve something like this? I'm hearing crickets. Is that a no? So remember, if you have an E, and we talked about exponentials and logs being inverses of each other, I could take the log, and what happens when I do that, so I take the log of both sides, is this cancels out and this comes down to the bottom. I still have ln of 0.3 over here, which you can put in your calculator, but I'm going to do it at the end. Still solving for x, so I divide both sides by negative 0.01. And then I take all of this and I plug it into my calculator, and it gives me approximately 120 tubes.